And you'll see that I've highlighted some of them. That's just to keep me from wandering around. I want to be sure and get to these that I've highlighted. And then if we scroll by any of them that pique your interest, then we'll stop and do those. Otherwise, I'll just keep doing the highlighted ones. Okay. All right. Now let me see. Sometimes I number sequentially all the way front to the back. And sometimes I restart the numbering with chapters. It looks like. All right. If I restart numbering with chapters, that means I've got to identify the chapter for each number set. But in this case, it looks like they're numbered from front to back sequentially. So let's look at number 2. In which of the following pairs of properties are both properties chemical properties? Remember the difference between a property, and a change. A property speaks to potential. What kind of potential does it have? Physical or chemical potential? So we're looking for a statement of potential in this case. And both of the identified properties in A through D need to be chemical properties in order to answer the question. Okay, so how about the first one? Freezes at 10 degrees. That's a physical property, right? Now, non-flammable is chemical, but they're not both chemical, so A can't be it. Decomposes at 500 degrees Celsius. That's a chemical property. Reacts with bromine. Is that a chemical property? Yeah, I mean, that the magic word is reacts. Right? So the answer to that one is B. And test taking technique. When you've got multiple choice questions, you know that if there's not any oddballs in there, like 2 of the above, all of the above, none of the above, those type of things, you can work your way down. And when you find the answer, you can stop. So we found our answer, B. All right, let's take a look at number 13. Which one of the following statements about atoms is incorrect? Keep an eye out for those little clue words that can throw you off. If you just say which one of the following statements about atoms is, and you just fill in the blank with correct, then you're going to get the wrong answer. Watch out for those words. We're looking for the incorrect one. All right, so A says an atom is the smallest piece of an element that can exist and still have the properties of the element. Is that true? Yeah. Yeah, that's the smallest part of it. It's part of an atom that still has the identity of the element. Smallest part of an element that still has its identity. B, free isolated atoms are rarely encountered in nature. Now, we didn't talk about this in class. This is something you'd have to pick up in your textbook. But it is true. We rarely encounter isolated atoms in nature. Now, there's some places in deep space where you can see individual atoms, but we don't encounter them here at home. They're always combined with something, or they're always a whole bunch of them. Like even in a flake of gold, there are billions of gold atoms in just that little flake. So this one's true. How about C? Atoms may be decomposed using chemical change. I don't think so. In order to decompose an atom, break it into its elementary parts, you need a nuclear process. Chemical processes don't do that. All right, so C is false. And we found our answer. D must be true. Only one kind of atom may be present in a homoatomic molecule. Yeah. you have a homoatomic molecule, what does that mean? There's only one element, right? All right, so examples like that. Let's see, or any of the diatomics would fit that because it's just one element, but they're molecular. Am I boring you? Yeah, okay. If I hear snoring, I'll have to pick up the pace. 21. Which of the following is a property of both the liquid state and the solid state? And so if we got these three states that we're only interested in, we've got a solid here, a liquid here, and a gas over here. Right, the solid has what? A definite shape. It has a definite volume. Definite volume for liquid, that's true. Indefinite shape though, right? And this one has indefinite for both of them. Let's see, shape and volume. So back to the question, which of the following property of both liquid and solid states? Liquid and solid states, it would be this one. Solid and liquid both have a definite volume. Let's see. A definite shape, no. Indefinite volume, no. Indefinite shape and definite shape, no. More than one, no. There's no correct answer there. That was sneaky. Let's see, I think I have a do with it here. I think I have something for you, Tiffany. Yep. Yeah, you submitted this safety quiz online, didn't you? I'm having trouble with my computer. I haven't been able to take images and create PDFs out of it. I'm working on the fix. But usually when you turn them in online, I'll give them back to you that way. All right, 22. In which of the following pairs of properties are both properties physical properties? Okay, we did one, the first one we did was chemical properties. Now we're looking for the pairs that are physical properties. A says melts at 73 and decomposes upon heating. That's physical chemical, that pair. Is good reflector of light, blue in color. But those are both physical. Has a high density, physical, very hard, physical. More than one correct response. Oh, and you were just going to let me go on, weren't you? I was thinking chemical the whole time. I mean, after the first one. Melts at 73, decomposes, no. Good reflector, blue in color, yeah, that's right. B is correct. But when you have that more than one correct or no correct, that means you got to look at all of them. And then C has high density and very hard. That was correct. So more than one correct response is the correct answer because A and C are both fit the bill. Y'all going to keep me honest. That's your job. All right, 30. Which of the following statements concerning elemental abundances in the Earth's crust is correct? Let's see. One element accounts for over 1/2 of all atoms present in the Earth's crust. Yeah, that's true. Remember which one it was? You're breathing it right now. Oxygen. Oxygen. Most of the elements in the Earth's crust are combined with oxygen in some form. Like iron ore is going to have that compound, and you got to get it loose from the oxygen to just, we call it smelting. We do the same thing with aluminum. Let's see. There we go. And a host of other elements. There are very few elements that are not combined with oxygen in the crust. Gold is a good example, right? You can pan for gold and get pure gold nuggets. It's what's called a noble metal. If it were more common, you could do that with platinum too, but platinum's not as common as gold. In fact, I think it costs more. Platinum does. I used to have a set of crucibles. We use them for some types of reactions because they're very resistant. They're very non-reactive. And they're made out of pure platinum, right? We only used them occasionally. And when we weren't using them, we kept them in the safe. Okay, back to the question. Let's see. Yeah, one element accounts for over half. That's true. Let's see. More than one correct? No correct? All right. E can't be it because we found one that was correct. But is there more than one correct? Silicon and aluminum are the two most abundant elements. No, they're not. They are abundant, but they're not the most. Elemental abundances in Earth's crust closely parallel elemental abundances in the universe as a whole. No. What's the most abundant element in the universe? The simplest one, hydrogen. That's because, I think it's 90% of most stars is hydrogen. And then you have helium and some others. Depends on how old it is. Right. When a star gets to the point, it's making elements as it goes, heavier and heavier and heavier elements. When a star gets to the point where it's making iron, its days are numbered. Because iron is the most stable nucleus in the periodic table. So it all from lighter to heavier, or from heavier to lighter, they all converge on iron. All right, so the answer to 30 is A. That's the only one that's true. 33. Which of the following pairings of terms or concepts is correct? All right, so they got to match up. A, atom and limit of physical subdivision. Limit of physical subdivision. Not necessarily. Right? If you have a compound, then you can only reduce it to a pure substance of the pure compound. If you have a mixture of, say, we're going to do an experiment, a mixture of salt and sand, sodium chloride and sand. You can separate those physically, but you can't get the sodium out of there apart from the chlorine without chemical means. Right? Physical subdivision won't do it. Right? You have to break bonds to get elements out of compounds, and that's chemistry. So A is false. B, molecule, limit of chemical subdivision. No, limit of chemical subdivision is the element. Let's see, C, compound, homoatomic molecule. True, true, false, false, right? Compounds must be at least two different elements together. Right? You can have a molecule like this, that's homoatomic, but compounds must be heteroatomic. You got to have more than one. So C is false. No correct response. Struck out again. How about 34? In which of the following pairs of chemical formulas do both members of the pair have the same number of atoms per molecule? In which of the following pairs of chemical formulas do both members of the pair have the same number? Okay. Right. So you got, let's do this one on the board. D and, oh, I see. So the only ones that actually have compounds are this one versus this one, H2C3, and then COCl2 and CO2. That's tricky. O2N2. I don't know why they wrote it that way. I would have written it N2O2. Oh, yeah. And then this is more than one, and this is no correct response. So the question is, how many atoms are in each molecule? 1, 2, 3, 4. So that's 4. 1, 2, 3, 6. Right, so that doesn't work. Let's see. 1, 2, 3. 1, 2, 3, 4. Notice the difference? That's cobalt. This is carbon and oxygen. And so if you ever develop the habit to block print everything you write, get out of that habit. Because in chemistry, it's going to kill you. You got to be able to write capital and small letters. Let's see, there's 4 here and 4 here. There you go. C is the answer. All right, let's see. 46. Let me see if I put any bonuses in this one. Yeah. Yeah, there are a few bonus questions in this one. Let's see how many. 47 points required and 10 points bonus. All right, 46. For the elements calcium, iron, and beryllium. Right? What's calcium? Ca, And what was the other one? Iron, and beryllium. Be. I didn't hear the E part. Okay, what are we supposed to do with this? Choose the appropriate characterization of the set's chemical symbols from the response list. Oh, all symbols have one letter. All symbols have 2 letters. All symbols start, well, let's see, have 2 letters. I'm looking at the wrong one, 46. All symbols have 2 letters. Yeah. They don't start with the same letter. Okay. So this would be, B would be the answer to this one. How about 47? What do we have here? Silver, sodium, and potassium. Sodium and potassium. I'm sorry? Okay. We can see what these have in common, right, without even looking at the answers. They're all derived from the Latin, right? Argentum, natrum, and calcium. So let's see, is there one in there that fits that bill? All symbols start with a letter which is not the first letter of the element's English name, D. All right, And 48. Iodine, fluorine, and nitrogen. Iodine. Fluorine. And nitrogen. Okay, let's see which of those fits. I see all symbols have one letter. That's true. All symbols start with the same letter. No. Okay. A has to be it. They're all just one letter. Oh, we're still got a roll. 49. Okay. Gold, lead, and bromine. Everybody needs to know that one. Huh? Bromine. Huh? Okay, now what's the question? 49. All symbols have one letter. Nope, not two letters. All symbols start with the same letter. Nope. All symbols start with a letter, not the first letter of the elements. No, wait a minute. Oh, yeah. Yeah, they all have two letters. 50. Let's see. Silicon, sulfur, and iron. And 10. Yeah. Oh, those all start with the same letter, right? That's it. C, they start with the same letter. Okay. Good. Very good. Now, did you already know these or did you learn them this semester? Using flashcards? Okay. Did you know them already? Okay. Yeah.
You got your table, you had a list of, there was ones that we needed to learn. We could do that, I could not find it in the stuff I got. And I've just been doing the entire thing.
A lot more work than you need. Anybody else need an extra one? Couldn't find it in Brightspace?
I didn't even look at Brightspace. I was looking through the papers thinking I'm going to buy it.
Okay. Yeah, when all else fails, go to Brightspace. I duplicate everything in Brightspace. It's in there somewhere. I've even used it. When I can't find my copy, I go into Brightspace, get a copy. Okay, 54. Give the classification of matter when two substances exist with two phases present and the substance cannot be decomposed by chemical means. Two substances, two different phases, and the substance cannot be decomposed by chemical means. All right. You do have, let's see, two substances in two phases. Well, if you can't decompose it by chemical means, it's got to be an element, right? But if there are two substances, it's a mixture, correct? Oh, no. I'll take that back. You can have two separate phases with an element. For instance, we used to use liquid nitrogen to freeze plant material and then stick it in the freeze dryer and remove all the water that way. We call it lyophilizing. But the nitrogen, the liquid nitrogen comes out of a big tank, and you can either use come out of a siphon and get the liquid, or you can take the gas off the top and use that gas for other purposes. So that's a case where you have an element where two phases are present and it cannot be decomposed by chemical means. Okay? That one stumped me for a minute. All right, so D is the answer. It's an element. How about 58? A substance is composed of diatomic molecules. Okay. So there are two atoms in the molecule. Choose the appropriate classification from the response list. Could be an element or a compound. Yeah, that's true. Right. All you need is an example. Right. There's our diatomic element. And here's let's see, diatomic molecule. Right. Both will kill you if you breathe them. Just word of warning. Rest of them don't match. I mean, we found the answer. I don't know what more I can say about that one. 66. Which of the following substance is both homoatomic and tetraatomic? Okay, homoatomic means it's got the same elements, and there are four of them. So which one fits that bill? P4? Yeah, P4, C. It's homoatomic, it's only got one element, and there are four of them. Tetraatomic. 67. Which of the following substances is both heteroatomic and triatomic? So it's got to have two or more different elements, and there are three. Yeah, that's the only one, actually, that's the only one that's got three atoms in it. So that ought to be a giveaway right there. HCN. Hydrogen cyanide. Both of these, P4 and HCN, are hazardous. This is what's known as white phosphorus. I don't know if you've ever seen it, but it's very reactive. Used to make a lot of it. Well, used to make a lot of white phosphorus and red phosphorus before governments started restricting it and gave the workers some protection. People were dropping like flies, working in the industry, and they were just not surviving very long. All right, now we're into chapter 2. But the numbering is sequential. 71. Okay. The mathematical meaning associated with the metric system prefix. Okay. Centi, milli, micro. Centi, milli, and micro. Right. So the prefix letter for this one is C. Prefix letter for this one is little m. And the prefix for this one is the Greek mu. But what do they mean? When we put these in front of a base unit, how does it modify the unit? Right? The centi modifies the unit by taking 100th of it. So the size of the unit decreases by 100th. Milli decreases by 1,000th. And micro decreases by 1,000,000th. So that would be B. B would be the answer. Right. 72. Yep, 72. I have to use my own. I'm going to use my own eraser. Mine's got a magnet in it. We'll keep dropping on the floor. Which of the following sequences are the metric system prefixes listed in order of decreasing size, largest to smallest? All right, what do we have here? We got kilo, giga, and mega. Kilo, giga, mega. And we've got milli, nano, and micro. Milli, nano, micro. We already used mega, we already used kilo, micro, pico, and deci. Pico and deci. Okay. All right, so what do each of these mean? How about pico? Remember that one? 10 to the minus 12. Yeah, 10 to the minus 12. The nano is 10 to the minus 9. Then micro is 10 to the minus 6. Milli is 10 to the minus 3. Mega is 10 to the third, 10 to the, excuse me. This is 10 to the third. This is 10 to the 6th. This is 10 to the 9th. And deci is 10 to the, nope, sorry, 1/10. So, we want to get them in order of largest to smallest. So kilo to giga won't work. That's small to large. Milli to nano. Milli to nano is okay. Micro, though, goes the other direction. So we can't do that. C, mega, kilo, and micro. That one works. Yeah, C works. Okay. All right. 73. Which of the following is an incorrect pairing of terminology? Okay. A, B, C, and D. Let's see, kilogram metric unit of mass. We're looking for the incorrect pairing. So kilogram refers to mass, that's true. How about B? Milliliter unit of volume. Milliliter volume. That's true. Meter, metric unit of length. Yep. That fits. So by process of elimination, I bet D is wrong. Cubic centimeter and metric unit of length, right? That was wrong. D is the wrong one. $76. Trombones. In which of the following pairs of measured numbers does each member of the pair contain the same number of significant figures? All right. Let's see, 10.3 and 10.30. This one's got 3 and that one's got 4. Right. Remember the rules. That 0 is significant because there's a decimal there. That 0 is significant because there are 2 non-zeros bracketing it. Just like that one. Right, so this one has 4, that one has 3. 800.0 and 80. This one has 2 and this one has 4. 0.0330 and 0.0333. Oops, I left out a 3. There we go. That one has 1, 2, 3, 4. This one has 1, 2, 3. All right, these zeros are not significant. These are not significant. That one is. And the last one, 0.000 4 zeros. 96, is it? Yeah. And then 96000. Correct. This one has 2. This one has 2. So D's the answer. All right. 79. Let's see. Can I squeeze both of them? Yep. 79. The measurement 8310.9. 9. Expressed in scientific notation. Remember the rules for scientific notation. Coefficient and power of 10. Coefficient has to be between 1 and 10. So we got to take this decimal and go 1, 2, 3. 8.3109 times 10 to the what? Well, if we move it to the left, coefficient, the number's getting smaller. So that means this one has to be bigger. We moved 1, 2, 3. So it's got to be a positive 3. And you can check yourself, right? That's 1,000. 1,000 times this would be over here, just like that. That makes the answer D. And we keep all of these are significant. So they stay in the coefficient. '81. The calculator answer obtained from multiplying the measurement 64.49 times 6.57. We have to assume this is correct. You can check it out. 423.70. That's what the calculator says. What can we report? Remember, multiply divide rules are the easiest. You just find out the least number of significant figures in your operators and apply it to the answer. So this has 4, this has 3. We'll have to round to this position. So 4, 2, 4. And that would be C. Okay. All right. Moving on. Now we're going to do some unit conversion, it looks like. 84. According to dimensional analysis, which of the following is correct setup for the problem? How many milligrams are there in 85 kilograms? 85 kilograms. And we want to go to milligrams. We're not actually going to calculate it. We're just going to set the problem up. All right. It looks like they're giving us a two-step problem. So we got a chain conversion. We're going to convert this to 1 unit and then convert that to the next unit. And the simplest way to do it is to convert this one to grams and then convert grams to milligrams. So when you set up your conversion factors, you want kilograms on the bottom because you want to cancel that out and leave grams behind. So 1 kilogram is 1,000 grams. Then we want to cancel grams and leave milligrams because that's our desired unit. What's the ratio here? Well, you can do it one of 2 ways. You can say 1,000 milligrams in a gram or 1,000th of a gram in a milligram. So we can start like this and see if it matches anything here. Let's see. I don't see anyone that matches. Maybe what we need to do is reverse one of them. How about this one? Make that one 1. Make this one 10 to the minus 3. See if we can find one of those. Yeah, B. B looks like a good candidate. Okay. All right. 87. If object A weighs 6 grams and has a volume of 3 milliliters, say A is 6 grams, right? And a volume of, it looks like we're going at density. 6 grams and 3 milliliters. Right? And object B has 9 grams and 2.25 milliliters. 9 grams and 2.25 milliliters. Correct? Yeah. B is less dense than A and B are equal, B is twice as dense. Oh, so we need to calculate the exact values. This one we can do in our head. Right? That was 2.0 grams per milliliter. Remember, anything you do to the numbers, you got to do to the units. Right? So we divide the units also. This one, I don't trust my brain to do that one in my head. Sometimes I can, but it's not working too well today. So this one's 4 grams per milliliter. Okay, I'd say B is twice as dense as A. They're not equal. B is not less. B is twice as dense as A. C. That fits. I should have been able to do that one in my head. '89. Which of the following comparisons of the size of a degree on the measured temperature scales is correct? All right, so let's see. We're going to have to look at each one of these, I think. For A Kelvin degree is larger than a Celsius degree. Is that true? No, they're exactly equal, right? So A is false. A Fahrenheit degree and a Celsius degree are equal in size. Nope, that's not right either. A Fahrenheit degree is larger than a Kelvin degree. That's not right either. Fahrenheit degree is smaller than a Celsius, which makes it smaller than a Kelvin also. So the last one must be it by process of elimination. The Celsius degree and the Kelvin degree are equal in size. Yep. That's true. So if you have Celsius, all you have to do is add 273 to it, you get Kelvin. How about the other one? If you want to know Fahrenheit from Celsius, your book probably says 1.8. Right. I do 9/5. Nine-fifths also allows me to estimate. You ever drive by those temperature things on the bank signs, and they're switching. They give you some type of advertisement, and then you give you temperature in Fahrenheit and temperature in Celsius. When you're driving too fast, I need to stop and look for the one you want. So if I see Celsius, I know that the relationship is for 20 degrees Celsius is 68 degrees Fahrenheit. Right? So if it says 25 degrees Celsius, I know it's 9 degrees higher. 25. Because the ratio is 9:5. And then you can bracket it in the middle and sort of estimate. That's just what I do to keep my mind active. 92. All right. In which of the following pairs of units is the first listed unit 1,000 times larger than the second? Well, let's see. D and E are the oddballs, so we have to look at A, B, and C. A, let's see. So milligram and nanogram. So milligram and, well, let's do it correctly. Milligram versus nanogram. Second one is liter versus centiliter. Liter, centiliter. Kilometer, megameter. Kilometer and megameter. What we're looking for is the first is 1,000 times larger than the second one. Right? So a milligram is 10 to the minus 3. Nanogram is 10 to the minus 9th. So what's the difference between 3 and 9? It's 6. That's 1,000,000 times. 10 to the 6 is 1,000,000 times difference. In fact, the first one is 1,000,000 times bigger than this one. Right? So it can't be that one. How about this one? Centiliter. That means that this is 100 times. Because centi is 100th of. And a megameter is 1,000,000 meters. And a kilometer is 1,000 meters. That's the one. The difference here is 3 orders of magnitude, just 6 orders of magnitude is 1,000. 3 is the difference. See it? I mentioned orders of magnitude before, didn't I? I'll say it again. Order of magnitude is power of 10. So if you have a power of 10 here and a power of 10 here, just subtract the smallest one from the largest one, and you see how big the largest one is compared to the first one. Wait a minute, that's not right. No, it's the other way around. Right? This is 1,000 times bigger than that one. The question is this one 1,000 times bigger than that one? And no, it's not. Right? You're going to let me get away with it again. You guys got to stay on your toes. So there's no correct answer. E. Right? What do they say? Mouth is moving before my brain's attached. Or brain's hitched. That's the terminology. I think I heard that on Gunsmoke once. I watch old reruns of Gunsmoke. Yeah. Marshall Dillon and Festus. And who ran the saloon? Kitty, that's right. Okay, in which of the following sequences of measured numbers do all members of the sequence contain 3 significant figures? All right. It's easier to look from here. 303, 330, 3.30, and 0.033, right? This is 3, and this is 2. All right, so A is not it. 78,000. 00780 and 780. That's 2, that's 3, and that's 2. That's not it. How about 30.0, 0.300, and 30100. Right, this is 3. That's 3, that's 3. Right. C is your answer. Five. Which of the following statements concerning the measured number 0.3030 is correct? Only one of the zeros in the number is significant. Nope, A is false. That one's significant and that one's significant. How about B? Rounded off to two significant figures, the number becomes 0.30. Let's see, two significant figures right there. Yep, 0.30 because that's less than 5. B is correct. We got oddballs down there, so we got to do C also. That one's good. How about C? Expressed in scientific notation, the number is 303 times 10 minus 2. So we go 1, 2, oops. Oh, we only need to move 1. 3.030 times 10 to the minus 1. All right, so this is the only good one. B. '97. Which of the following measured numbers contains 3 significant figures and has a magnitude of less than 1? Okay, we can process of elimination here. Magnitude of less than 1, that means the power of 10 is minus. Right? So it has to be B or C, or it could be more than 1. 3 significant figures. Yeah. 3.00, 3.20. Those both have 3 significant figures and they're less than 1. Right? So D is the answer. Both of those are correct. Which of the following measured numbers has an uncertainty of 0.01 associated with it? All right. We didn't look at this too closely. A, B, C. Yep. So our first example is 32.390, correct? 302 times 10 to the 6th. 0.02 times 10 to the 6th. And 3.0 times 10 to the minus 1. Okay, when we're looking at uncertainty, 0.01 is in standard notation. This is the only one in standard notation. So we're saying that the uncertain digit out here is 0.001 in that position. All right, so that can't be it. This one, the uncertain number is this one, right? And it's uncertain to 3.0.2.0.6. 1, 2, 3, 4, 5, 6. Okay, so it's uncertain to that position. That can be it. So it's either this one or none. So this one in standard notation would be move to the left 0.30. It's uncertain in the hundredths position. That's what they mean by uncertainty 0.01. It's uncertain 0.01 position. Okay. That's C is the answer. I think that's why I picked that one, because it could be confusing. 102, which looks like a definition. Density can be used as a conversion factor to convert from, all right, density is mass per unit volume. So if we solve for each of these 3, that's solving for D, we can solve for V, M over D, or we can solve for M. And M would be D times V. Correct? Conversion factors are always ratios, right? So you can't use that one as a conversion factor. It won't work. It's either this one or this one. you can convert from mass to volume or from mass to density using these conversion factors. So which one fits that one? A, mass to volume, or volume to mass, either way, right? Remember, all conversion factors are equal to 1, so you can flip them. So A and B are true. Metric unit mass to English unit, I don't think so. So 2 of the above are correct, A and B. Did I lose you? Example. If we have like 10 grams and we want to convert to volume, then we would need mass on the bottom, grams on the bottom, and milliliters on the top. So we would put this one on the top and this one on the bottom. Okay, and that would be a value of density. So some number here, grams per milliliter, would give you, cancel the grams and leave you with milliliters. That's what we're saying. (103). The density of table sugar is 1.59 grams per mil. 1.59. Is that your experience? Say you have a glass of iced tea that's not sweet, and you put sugar in it, right? What happens to the sugar when you throw it in there? Before you mix it, right? This is an experiment, so don't mix it first. Drops to the bottom, doesn't it? Yeah. So its density has to be greater than 1. That's the density of water, and we have to assume T is pretty close. All right. It is true that 2 grams of table sugar occupies a volume of 1.17 milliliters. All right, so we're saying we're converting grams to milliliters for each one of these 3. A, B, and C. So the first one is 2 grams. Second one is 3 grams. And the last one is 5 grams. So we want to convert each one of these, Henry Ford, we want to convert each one of these to milliliters. How do I know that? Because the answers are set up that way. Occupies a volume of some number. Right? So for each one of these, I'm going to use the same value, 1.59 grams per milliliter. Okay. Let's see. Yeah, I better calculate them. 2 divided by 1.59 is 1.26 milliliters. 3 divided by 1.59 is 1.89. And 5 divided by 1.59 is 3.14. There we go. So now we can look at our answers. Let's see. 189, 170. Here we go. That one right there. C. All right. And let's see here. Skip a few. Oh, we're into chapter 3. All right. 120. The nuclear charge for an atom of fluorine. Nuclear charge. What are you talking about? What's in the nucleus? Uh-huh. Yeah. There's only one case where there are no neutrons. Right? Hydrogen. One of the hydrogen isotopes. Right? So what's the nuclear charge? Well, it's always positive, right? And since there are 9 protons here, that's your nuclear charge. Plus 9. How about 121? The quantity A gives the number of what? Remember our example? There's the charge. There's the number of atoms. There's the Z number, which is the number of protons, atomic number. And A, the mass number. The mass number is protons plus neutrons. So, let's see, electrons, neutrons, nucleons. We never used that word before, did we? A nucleon, what's a nucleon? It's anything that resides in the nucleus. Right? That's equal to protons or neutrons. So that A is the number of nucleons in the nucleus.
I'm okay, it says 1, 3.
Oh, mine says C, but your answer says B.
The P says big, in the question.
Okay, that's wrong. That was a typo. 121. Yep, says D. That is not correct. It's C. 121 is C. Okay. No. If it says D and it's a different question, then let's leave it alone.
Says the quantity equals the number of.
A plus Z?
Plus Z, it's not up there.
Yeah.
Everything else is exact.
Okay, that is true. That's all the subatomic particles in an atom, because the number of electrons would be equal to Z. So if we say Z in a neutral atom, Z is the number of protons, but it's also the number of electrons. So if you had Z as the number of electrons, plus A, which is protons and neutrons, you get all the subatomic particles, right? That's a true statement. It's just not on this document. Okay? All right. All right, so I'll leave that alone. What I need to do is, see, what should I do? Correct this copy? Maybe I should correct this copy. So it's written as A. Oops. Sorry. I forgot. I'm in Acrobat. Gotta edit the text. Here we go. 21. A plus, come on, there we go. Z gives the number of subatomic particles. There we go. Now it jives with your copy. All right. Uh, 124. Two naturally occurring isotopes exist for a hypothetical element. Dipium. That better be hypothetical. 25% of dipium atoms have a relative mass of 17 AMU. So we got dipium. What's its symbol? Di. So 25% have a mass of 17. So 25%, we're going to use fractional, have 17 AMUs as their mass. 75% have 21.3. And 75%. Okay. What it's going to ask us is, what's the atomic mass of dipium? Okay. So we just need to take a quarter of 17. And that's 4.25 and 3/4 of 21.3, which is 1.60. 5.85, let's see. 17 is, 17.0, good. So we can keep all three of them. Well, that's not right. I did something wrong. There it is, right there. 16.0. Or 5.2. 16.25 or 16.3. Here we go. That's not it either. What did I do wrong? Oh, well, my brain's not working today. 20.3. Right. 20.2. All right. Here's a lesson in test taking. When you got multiple choice and you have none of the, so you don't have none of the above or those, pick the best answer. Closest one to this is 20.2, which is C. So what we have here is probably a rounding error. Now, if you have the option, none of the above, you could put that and then argue with me. Okay. All you got to do is show me your work. 125. The modern periodic table arranges elements in order of what? Number of protons, yeah. Yep. The atomic number dictates the order of elements in the periodic table. In which of the following pairs of elements are both members of the pair in the same period in the periodic table? That means the same row, correct? All right, so let's say A, B, C, and D. A, B, C, D. So A is neon and magnesium. Let's see, there's neon, magnesium. Neon's in the second period, magnesium's in the third, so that one can't be that. How about nickel and palladium? All right, those are transition metals. They're in the same column, but they're not in the same period. Right? Calcium and selenium. Let's see, calcium's in the fourth period, going across, there you go. They're in the same period. We found our answer. Oops. $128. The correct electron configuration of chlorine All right. If you haven't been practicing this, it's going to seem like Greek. 1s2, 2s2, 2p6. So we've used up 10. We've got 7 more. 3s2, need 5 more. 3p5. So 5, 6, 7, 13, 4, 17. That should be it right there. C. Okay. Let's see here. 131. How many unpaired electrons are present in the orbital diagram for an atom whose electron configuration is 1s2, 2s2, 1s2, 2p, 4. Okay, 4, 5, 6, 7, 8. So that must be oxygen. These are paired, right? All the S's only have 1 suborbital. P's have 3. So these are paired. These are paired. 1, 2, 3, 4. There are 2 unpaired electrons for this one. Okay. Hund's rule. There's, in the suborbitals, you have to unpair them first until you have more than 3 here. Then you can start pairing them up. $135. Which of the following statements correctly describes the subatomic particle called a neutron? Let's see. Has a mass slightly less than that of a proton? It's the other way around. Slightly more than a proton. Not found in the nucleus. That's wrong also. Who discovered that one? Do you remember? The neutron. It was Rutherford's research associate, Chadwick. Has a positive charge. Nope. Only when it loses an electron, then it becomes a proton. But that's not chemistry, that's nuclear physics. So none of them are correct. 136. Let's see how we're doing on time. 10, we got till 10:50. We should get finished. Which of the following statements concerning the nucleus of an atom is correct? It accounts for almost all the mass of an atom. Yep. A is true. How about B? It's always positively charged. Here we go again, because it's only got protons in it with a charge. It contains only neutrons. No. More than one correct response, D. That's correct, yeah. $137. Which of the following collections of subatomic particles possesses a net charge of +2? Subatomic particles possess a net charge of +2. Oh, we can have more than one. 2 neutrons and 2 electrons. No, that's a net charge of -2. Let's see, 3 protons and 1 electron. So 3 minus 1 equals +2. That's it. Well, that's one of them. 3 electrons and 1 proton is a -2. Okay, so we found our answer. It's B. $142. Period number and group number in a periodic table are numerically equal for which of the following elements? Aha, okay. Got A, B, and C. And we got aluminum. We got arsenic and antimony. So we want the group number. All right. In this case, the group number is the Roman numeral number. I think that's what they're getting at. So we got Roman numeral 1 and 2 on the left-hand side, and then we jump over to boron, and that's Roman numeral 3, 4, 5, 6, 7, 8. I think that's the only way we're going to get the right answer. All right, how about aluminum? Aluminum is in the third period, and it's in the third column. All right, so aluminum works. How about arsenic? Arsenic is in 1, 2, 3, 4, 5, but it's in the fourth period. Fifth group, fourth period, that doesn't work. Antimony. Antimony's in the sixth. And 1, 2, 3, 4, 5. That one doesn't work either. So A should be the correct answer. More than one correct response. Period number and group number. Aluminum is 3 and 3. Okay. Did I read those wrong? Arsenic. Yeah. Yeah, you're right. It looked like a 6 from here, but no, that's right. This one's correct. Yeah, that's right. Group number and period number are the same for antimony. So D is the answer. Which of the following periodic table groups contains 3 or more non-metal elements? All right, so we got 3, 4, and 5. 3, 4, 5, and these are all A's. And we're looking for 3 or more non-metal elements. Well, the further to the right you go, the more likely you are to get more non-metals in the group. All right, so 3 only has 1 non-metal. 4 has 2, copper and silicon. 5 has nitrogen, phosphorus, and arsenic. Right, so that's it. Okay. 145. Which of the following electron configurations corresponds to an element in the same group of the periodic table as the element whose electron configuration is 1s2, 2s2, 2p5? So what we need is a group that has 7 valence electrons. Right? 7 valence electrons means the 7th group, which is the halogens. So what we need is, let's see, the first one is 2s2, 2p4, can't be it. 2 and 6 can't be it, that's a noble gas. How about, let's see, C can't be it either because its valence electrons are only 2. Right? There's no correct answer there. You'd have to have a 3s, a 3s2, and a 3p5, for instance, or a 4s2 and a 4s and a 4p5. Those would work. Okay. So this would be 5, 6, 7, 8, 9. This would be fluorine. This would be chlorine, and this would be bromine. That's the only way you could work it. They'd be in the same group. I see some puzzle faces. That will snow you? Or did you already know that? You're just being polite. 146. Two unpaired electrons are present in the orbital diagram of which of the following elements? Well, let's see. Two unpaired electrons. Well, let's see. We've got carbon, neon, and magnesium. Magnesium is 12. Well, you know it can't be neon because they're all paired. All its orbitals are full. We don't even have to bother with that one. Magnesium, let's see. Just checking my question. Two unpaired electrons are present in the orbital diagram. All right. Magnesium has full orbitals up to 3s. 3s, and that's two electrons there. Those are paired, right? So it must be carbon. Let's see what carbon looks like. 1s2, 2s2, 2p2. Yep. That one's empty. So carbon's your answer. Let's see. Oh, by the way, these types of questions where you have to look at the three statements, 1, 2, and 3, and see how many of them are true. Those are the types I put in extra credit. And we haven't talked about any of those. Because I wanted to be sure and get through all these others. (162). Choose the correct atom that has a nuclear charge of plus 17. Nuclear charge of plus 17. All right, well, that would be chlorine, wouldn't it? Yeah, chlorine. And let's see, it gives you the A number. So that has 20 neutrons in it. (169). Okay. Choose the appropriate pair of atoms that contain the same number of subatomic particles. All right, when we say the same number of subatomic particles, we mean protons, neutrons, and electrons. So if we have A through D, A, B, C, D. Let's see, 6, 13, and 7. 14? No, that's 13 also. Okay. 1737 and 1836. C is oxygen and fluorine. 19. Okay. And the last one is lithium. We have 6 and 7. 6, 7. Are there any ions in there? No. Okay. So the number of protons equals the number of electrons. So how many subatomic particles here? Well, we've got 13 in the nucleus plus 6 electrons. So this should be 19, correct? And we have 13 here plus 7 is 20. That doesn't work. This one has 37 plus 17 electrons, which is 54, correct? 54 subatomic particles. This one is 36 plus 18 electrons is 54. That one works. We found our answer? Yeah, we found our answer. And you can bet that the others are not right. They won't be equal. See what I did? Like that question that was wrong, we thought was wrong. Right? This is the number of electrons. This is the number of protons plus neutrons. Since it's neutral, then we use that one as the number of electrons. It's number of protons, but in a neutral atom, it's number of electrons also. So 8 plus that one would be 26, and this would be 28. And this would be 9, and that would be 10. So those are wrong, those are wrong. B is the only answer. 175. Choose an appropriate pair of elements that are in the same period of the periodic table. Okay. Let's see, rubidium, the same period. Same period? Yeah, same period. Rubidium and strontium, they're right there next door neighbors. Okay. We go no further. We got our answer. Ought to be getting close. Yeah, we did. We are close. Those are the only ones I had marked. Were there any in there that piqued your curiosity? I didn't. I don't know why I didn't highlight some of these. Some of these where you have to determine whether they're true for the first one, the second one, the third one. We got time. Yeah, we got time if you want to look at a few of those. Okay. Let's see. I want to pick out, I want to use the same types that I've seen, that I've got in the exam. So at least have a fair shot at getting some of them. So this is chapter 1. Okay. See, do I have any of those in here? Since we're short on time, I don't want to waste your time doing types that we don't need. No, let's skip those. Let's. Sure. 47 and 10. Let me see. Yeah, because they're 1 point each. 47 on the required section and 10 on the bonus. So let me go down. I think these are going to be good candidates as soon as I find one. How about this one? 109. So we're going to look at these 3 statements and see how many of them are true. The first one is the addition problem 3.21, 32, and 3.22. 3.21. If we're going to should have uncertainty of hundredths. 32, line up the decimals, and 3.22. And so if we add these together, and 5, 8, 8, we can only keep it down to here. So its uncertainty is in the ones positions. The uncertainty here, it says it's in the hundreds. No, it's in the ones position. So number one is false. How about the second one? The measurement 653,899. 653,899. When rounded to 5 significant figures. So 1, 2, 3, 4, 5. How to round it to there. So this one becomes 10, 6, 5, 3. This one becomes 10. Carry the 1, and that's 9. But we got a whole place for that one. That's 1, 2, 3. That's only 4 significant figures. Okay, this presents a problem. Well, okay. If we were actually trying to say give us a number that had 5 significant figures, then the only way you can do it is to write it in scientific notation. Standard notation doesn't give you a vehicle to give you 5 significant figures out of that number, right? Because if you put a period here, if you put a decimal there, that gives you 6 significant figures. If you leave it off, then it's only 4. So we'd have to write it in scientific notation to guarantee 5 significant figures out of that number. But the question says 5 significant figures becomes 75390. Right? It's 653,000. It can't be 65,000. Right? That's nowhere near the same number. Right? So 2 has to be false also. In fact, we don't even have to deal with it. And 3, the higher the specific heat of a substance, the more its temperature will change when it absorbs a given amount of heat. Did we talk about specific heat? I think we did. No, we didn't. Oh, okay. Well, let me tell you. The specific heat for a substance, which we designate with a small s, is equal to the amount of heat in joules required to change the temperature of 1 gram of substance 1 degree centigrade. So if the number is higher, that means more heat is required to change the temperature by 1 degree for the same amount of mass. So a higher specific heat means it doesn't change as much for the amount of heat you put in it. The higher the specific heat of a substance, the more its temperature will change when it absorbs a given amount of heat. And that's false. It's the other way around. So all 3 of these are false. I thought we had talked about specific heat, but maybe we didn't. All right. So let's see. Let's look at. Still got a few more minutes. You feel comfortable with significant figures? You know the rules? No? Okay. So we won't waste time on that one then. Let's see. Let's go down. All right, we're into another chapter. Let's go down till we find some more. Oops, did I skip them? Nope, I didn't skip one. Here we go. Let's see. about 157? Well, at least you're getting a feel for what these questions, what you have to do. You got to look at each of the three possibilities and say how many of them are true. All naturally occurring atoms of an element must have the same mass number. Right? No, that's false. Mass number can be different for the naturally occurring elements, different isotopes. How about two? Protons and electrons carry the same amount of charge. Yeah. Protons positive. Well, amount of charge, not the same sign, but the amount is the same. Protons and electrons. So technically, that's true. An isotope of chlorine with A35 and Z17 contains more neutrons than protons. So how many neutrons? 18 neutrons. That's true, right? So you got two that are true for this one. Two of the three statements are true. I'm not sure where this one is. Desorption. You remember your principal quantum number is n, right? And it can be 1, 2, 3, 4 on up. And then L can be any one of these taken at 0, 1 up to n minus 1. And then m sub L can be one of these would be, excuse me, m sub L, minus L up to plus L by increments, whole number increments. And then m sub S is either plus half or minus a half. So we get the letter designations for this level are associated with, let's see, let me do another one out here. 2, 3. This one is S, P, D, F. So if I'm not using a specific one here. We're going to focus on D. If we have D, that means 2 can have m sub L's. Minus 2, minus 1, 0, plus 1, it's 2. Okay? What's the maximum number of electrons you can have at the D level? Well, that's 5, right? 1, 2, 3, 4, 5. 5 times 2 is 10 electrons. And that tells you, and that corresponds with the part of the periodic table where you're creating 10 elements across, transition elements. Right, so if you start with scandium, with the 3 Ds in scandium, count across, you've got 10 elements all the way to zinc. That's why, because you have 10 electrons that you're putting in each time you increment a proton. If we did the same thing with 3, that would be minus 3 up to plus 3. Well, that's 7 times 2 is 14. And that's for the actinides and lanthanides. Okay? The S group is the 2 columns on the left. P group is 6 on the right. Just a reminder. Well, I'm out of things to say.